Good morning, students. Today we'll discuss about the homogeneous differential equation from the chapter differential equation for class 12th maths. Okay, so let's begin with and let us try to learn what is homogeneous differential equation, and we'll try to solve the numericals based on that concept. Okay, so now the chapter which we were doing, which we have started, that is differential equation. Now you can see here the topic today is homogeneous. The topic today is homogeneous differential equation. Okay, now we all know what is differential equation. We all are aware about it. So what is homogeneous? Let us try one example so that we easily able to understand what is homogeneous. Okay, so I will I'm starting now exercise so that will become easier for us to understand what they have given. First, we all know what is differential equation. That is, without any constant a and b are to arbitrary constant, we have the differential equation. Now here the question is x square plus xy into dy is equal to x square plus y square dx. This is the question. So now let us see how we can describe it, that it is a homogeneous or not. How? See, dy upon dx. Take this side, and this x square plus y square upon x square plus xy. So now I can say let this is now fxy is equal to x square plus y square x square plus xy. Okay, now if I say replace x by kx and y by ky, so what will be there? Kx whole square plus ky whole square upon kx whole square plus kx into ky. Now here I have, if I take a kx square plus k square y square upon I have k square x square plus k square xy. We can take k square common from both. So I have got k square x square plus y square upon I have k square x square plus xy. So it will be, if I say 1, so I can write this k is for 0, because any variable, any number having the power 0 means 1. So now I have this k square plus y square upon x square plus xy. I have this, so I can write k is for 0 f x y. So I can say this is a homogeneous differential equation. So therefore it is homogeneous. It is homogeneous differential equation. It is homogeneous differential equation. Now what we can see here, that because having k0, that is, we can see here that the coefficient of dx and dy, they have the same degree. So we can say they have the same degree. So it is a homogeneous differential equation. Okay, the question arises, first they will ask that this differential equation is homogeneous or not. In second case, they will ask you to find the general solution. Now let us see how we find the general solution after finding that this equation is a homogeneous differential equation. So now let us try how we can solve this. Let y is equal to vx. Okay, now we'll do the substitution here. So now dy by dx, differentiate it, we got v plus x dy by dx. We know by by parts, or we can say uv differentiation we have done here. First function into differentiation of second plus second function into differentiation of first. So now I got this. Now here I can put dy by dx, but I can put this one, and here x square will try to put the value of this y vx. So we will got v square x square upon x square plus we have y. So we will be x square v. Okay, because x into y, x into vx. So x into x square v is equal to v plus x dv upon dx. Now next, take x square common, 1 plus v square upon x square common, 1 plus v. So I got v plus x dv upon dx. Now we'll try to solve here. This step will be now here. So what will happen if I 1 plus v square upon 1 plus v minus v is equal to x dv upon dx. So now 1 plus v square minus, if I take LCM here, 1. So no, if you we can take like this, 1 plus v. Okay. So we have 1 plus v is equal to x dv upon dx. So now if I say this 1 plus v square minus v square upon 1 plus v is equal to x dv upon dx. Now next step is what we can do here. We can shift these. So I got 1 upon x dx. 1 upon x I will take here x dx and it will be shifted to this side. So I will got 1 plus v upon 1 minus v. Okay, 1 plus v, 1 minus v, that is called dv. Okay, so now what we can do, we can integrate this. Okay, so you know 1 upon x is log x is equal to here. Now we need to integrate it. How we can do it in a very simple way? Let us see. Okay, we have 1 plus v. Okay, so now here I can write 1 plus 1 minus 1 plus v upon 1 minus v. So now I need to integrate this. What else I can do here? Now a simple way. Now 1 plus 1 2 minus 1 minus v upon 1 minus v. Okay, so now I got this. And is equal to log x. We have log of x. So now here is we have, if I open this, I will got 1 plus v. What I can do now? A simple way, just we can separate it out. So after separating, I got 1 minus v upon 1 minus v. We have dv, and this we can integrate is equal to log of x. Now what I got here, you can take log 1 minus v. We have minus and we have minus v is equal to log x. Now what we can do here, we can write what we have, substitute y is equal to vx, so v will be y upon x. So minus 2 log 1 minus y upon x minus y upon x is equal to log x. What we can do, take this side. So what I will have, log x minus 2 log 1 minus y upon x is equal to y upon x. Okay, so now what I can do, log x minus, we can take log x minus y upon x square is equal to y upon x. So we have this. I have taken this side minus, so it will be plus. Now I will take minus common, so log x plus log x minus y upon x whole square is equal to y upon x. We'll take minus sign this side. So now what I can put here, I can say log x into x minus y upon x whole square is equal to minus y upon x. Now we know that we have this, so removing log from both sides, I have x, we have here, that is x minus y upon x. So it's a whole square is equal to, here what I have, if I see this, we'll take minus y upon x, okay, minus y upon x plus c, this power c we have, so we'll take minus y upon square is equal to e raised power minus y upon x plus c into x we have, okay, we have, so we can put like this, x into e raised power minus y upon x, and this we can consider as plus c, okay. So, or I can take c like this here, okay, instead of here c, that is, and c is e raised power, okay. So that is how we can easily solve such kind of numerical. So now let us try to solve the second numerical. Now we have solved first one, now we'll try to solve second one, okay. So that is how we able to solve such homogeneous differential equation and find the general solution, okay. So now let us try to solve the second numerical. Now the second numerical I have, that is, what they have given is, let us see, they have given y dash is equal to x plus y upon x. We have y dash upon x, okay. So now what I can write, dy upon dx is equal to 1 plus y upon x. So I can say fxy is equal to 1 plus y upon x, okay, because I have separated out here. Or now I can replace x by kx and y by ky. So we have x, so I'll write here 1 plus ky upon kx. So I can say that is k upon k 1 plus y upon x, or we can say here f of xy, okay, having the same degree of the coefficients of dx and dy. So finally I can say, therefore it is a homogeneous differential equation, okay. So now what I can do here, now very simple way, let's try to take, let y is equal to vx, so dy upon dx is equal to v plus x d by dx. Now take dy by dx here, so we have 1 plus, now we will try to say what will do, vx, why will take vx upon x will be v is equal to v plus x d by dx. 1 plus v minus v is equal to x dv upon dx. Now 1, okay, 1 upon x dx is equal to dv. So what I have got here, let's try to solve here. Log x is equal to v plus c. Now log x is equal to, what is v, y upon x plus c, okay. So that is how we can solve. If you want to remove log, so it will be x is equal to e raised power y upon x dot c, okay. I can write here plus log c will be there, okay, here it will be into c. So I can write x is equal to c e raised power y upon x, where c can be e raised power c. Okay, so that is the required solution, general solution of the homogeneous differential equation. Now let us try to solve the third numerical. Let us see next differential equation is homogeneous or not. Okay, so now likewise we can see we have third question, that is x minus y. We have dy minus x plus y dx is equal to 0. So now let us try to solve. We'll take that side, x minus y dy is equal to x plus y dx. Now dy upon dx is equal to x plus y upon x minus y. Okay, let us see this differential equation is homogeneous or not. In a very simple way, I can say f of xy is equal to x plus y upon x minus y, or f of, if I replace x by kx and y by ky, so I got x plus y. So now I got kx plus ky upon kx minus ky, or I can take k upon k, x plus y upon x minus y. So I can write this k raised power 0 x plus y upon x minus y, because now here we have 1 and any variable or number having the power 0, it becomes 1. So that means therefore it is a homogeneous differential equation. Okay, homogeneous differential equation. Now let us try to what we will try to solve it. Let's take it y is equal to vx, then differentiating it dy upon dx, v plus x dv upon dx. Now putting this value here, x plus y will take vx upon x minus vx is equal to v plus x dv upon dx. Okay, so now we have this v plus x dv by dx, and here we have taken a dy upon dx. We'll put y is equal to vx. Now what we can do, vx upon x minus, when a very simple way, take x common, 1 plus v upon 1 minus v. So we have this v plus x dv upon dx. Now 1 plus v upon 1 minus v is equal to x dv upon dx. 1 plus v minus, if I take this 1 minus v upon 1 minus v is equal to x dv upon dx. So now open the bracket, 1 plus v minus v plus v square upon 1 minus v. So what will happen? I will get this is equal to x dv upon dx. Now here we can solve 1 plus v square upon 1 minus v is equal to x dv upon dx. So now take this that side. So what we'll have here? We have 1 upon x dx is equal to, if I take this, 1 minus v upon 1 plus v square. Yeah. So now it will be log x is equal to, let us try to solve this now. We have 1 minus v upon 1 plus v square. Okay, so now what we can do here, we can separate it, dv minus v dv. Okay, so now we all know 1 upon a square plus x square is tan inverse. So we have tan inverse x upon a minus, now we have this, what we can do, put 1 plus v square is equal to t, so that 2v dv is equal to dt, vdv is equal to dt. Half I will have here, we have v dv is a dt upon t. So now I can say tan inverse v minus half log t, we have log 1 plus v square, and here we have log x. So now what I can do here, put the value log x is equal to tan inverse. What is v here? We have taken y upon x minus half log 1 plus y square upon x square. We have this. Okay, so what I can do here, if I take this that side plus c, so log x plus half I can take square, so I can take log 1 plus y square upon, no, I have x square. Okay, so now what I have done here, that is square plus here we have tan inverse y upon x plus c. Okay, so that is what we have. So what we can do here, take log, we will have x into, because we have log a plus log b, log ab, so I have, if I take this common, x square plus y square ka whole square upon, I have x4, so I will have 1 3 left. Okay, so now tan inverse y upon x plus c. Okay, so like this we can solve such kind of numerical. Now let us try to solve the fourth question. We have just solved only 3. Now let us see that next differential equation is homogeneous or not, and if it is, then we'll try to solve the we'll try to find its general solution. Okay, so now we have the fourth question now. So now what we have, the fourth question, that is x square minus y square dx plus 2xy dy is equal to 0. Okay, so this is what we have. Now let us try to solve it. That is in a very simple way. So x square minus y square, okay, is equal to minus 2xy dy. I have taken that side, and here we have dx. So what we can do here, dy upon dx is equal to dy upon dx, so it will be x square minus y square upon 2xy, will take minus side this. Okay, I have taken this on that side. So now we'll try to say that this is minus x square minus y square upon 2xy. So now if I replace x by kx and y by ky, so what I got here, minus k square x square minus k square y square upon 2 into k square, we have put the kx ky, so it will be k square xy. Now what I can do, we'll take minus sign common, so sorry, k square upon k square, so we have x square minus y square upon, we have 2xy. So if I do this, I will got k is for 0, y square upon 2xy. So I can say is equal to k is for 0 minus of f of xy. Okay, we have this. This is f of xy. So I can say therefore it is a homogeneous. It is a homogeneous differential equation. Okay, so now we'll try to solve. Let y is equal to vx, or dy upon dx is equal to we have x. So I'll solve now x into dv upon dx. So we have differentiated, and by using the formula u we have applied it. Now here we'll apply dy by dx. We have minus x square, and we'll try to put the value vx. So we got v square x square minus upon 2 into x into y, we have vx. So we'll try to put x square v, okay, is equal to v plus x dv upon dx. So now we'll try to solve here. We have x square common, so we have 1 minus v square upon 2 x square v. So it will be reduced, is equal to v plus x dv upon dx. Now what we can do? Minus 1 minus v square upon 2v. Okay, we have this minus v is equal to x dv upon dx. We can take minus common. So we have 1 minus v square upon 2v plus v is equal to x dv upon dx. Okay. So my next step will be, let us see, we'll try to solve here, that is 1 minus v square plus 2v square upon 2v is equal to x dv upon dx. Okay, so now I have 1 plus v square upon 2v minus is equal to x dv upon dx. So now we'll try to find its general solution here. So we have this. Now we can take on that side, that is 1 upon x dx. We have 2v upon 1 plus v square dv minus. We have log x is equal to, we know that, put this t. So 2v dv is equal to dt. Okay, 2v dv is equal to dt. So we have 1 upon t, that is log t. So we'll got half here. Okay. No, 2v dv is equal to dt. So 1 upon t log t. So no need to put this. Log t is 1 plus v square plus c. Okay. So now we know what is the value we have taken here. V is equal to, y is equal to vx. So y upon x. So we'll have y square upon x square plus c. So I can take log x plus log 1 plus y square upon x square is equal to c. Okay, so now multiply, we got log x into x square plus y square upon x square is equal to c. So I got log x square plus y square upon x is equal to c. So we'll have x square plus y square, we'll remove the log, so x e s power c. Okay, x e s power c, or you can say xc, x square plus y square is equal to c, where c is equal to e raised power c. Okay, so finally we able to find its general solution. Now we'll able to find the fifth question now. Okay, we'll see which differential equation is given in fifth question, and we'll try to find its general solution if it is homogeneous. Otherwise, no need to find general solution if the given differential equation is not homogeneous. Now let us try to find the fifth one. Now they have given the fifth question, that is x square dy upon dx is equal to x square minus 2y square plus xy. Okay, so let us see whether it is homogeneous or not. Dy upon dx is equal to x square minus 2y square plus xy upon x square. Okay, so now we'll see, we'll try to put f xy is equal to, we'll try to see x square minus 2y square plus xy. So we'll say this x square minus 2y square plus xy upon x square. Now we'll try to replace x by kx and y by ky is equal to k square x square minus k square y square plus xy kx, k square xy upon k square x square. So we can take x square common, and here also, so we have x square minus 2y square plus xy upon, we have x square. So I can write this 0 is equal to f xy. We have the same coefficient, same degree of dy and dx coefficient, so we can say this is a homogeneous. So it is a homogeneous differential equation. Now let us try to solve it, try to find its general solution we have. So we have, let y is equal to vx, so dy upon dx is equal to v into differentiation of x plus x into dy dx. Now we can put this value here, dy upon dx is what we have, this, so x square minus 2y square, x square minus, we'll put the value y vx, so we'll got 2 v square x square plus x square into v, into x we have done, upon we have dx. What is dx we have here? dy upon x square, so we'll try to put it x square over. Okay, so is equal to v dv upon dx. We can take x square common and eliminate it. So we got 1 minus 2v square plus v upon x square. V dv upon dx. Wait, what we have done here, made a mistake. We'll write v plus x dv upon dx. V plus x dv upon dx. Now we have this. So now what we can do, we'll take this y this side. So 1 minus 2v square plus v minus v is equal to x dv upon dx. So 1 upon x dx, separating the variables. So now we have dv upon 1 minus 2v square we have. So now we have log x is equal to, now we'll try to differentiate it. What we can do here, let us try to put the value here. Okay, so now we'll try to put it as dv upon 1 minus root 2v whole square, this one. So now we'll try to integrate. We have log x is equal to, we'll try to put the formula here of dv upon 1 minus a square minus x square under root. No, we don't have under root, so we'll try to put this 1 upon 2a log a plus x. We have log a plus x upon a minus x plus c. Okay, so we have this plus c. Okay, here we can solve log x is equal to, we'll put the value of now 1 plus root 2 v, y is equal to vx we have taken, no? Y is equal to v, so v y upon x upon 1 minus root 2 y upon x. plus c. Okay, so now what I can do, take that square, log x is equal to log of x plus root 2y upon x minus root 2y, because by x upon x it will be eliminated, so we'll have this. So you can take that side, so log x minus log x plus root 2 y upon x minus root 2 y whole square is equal to c. Okay, so what will happen now, if I try to solve this log a minus log b, it will be log upon a upon b. So we have this, upon this will have okay, log a upon log b is equal to c, or we have x is equal to e raised power c, so we can take this directly there, is equal to x plus root 2y upon x minus root 2y whole square into e raised power c. Okay, so that is how we can easily find its solution here. C. Okay, where C is first. So that is how we try to find the general solution of the homogeneous differential equation. Now let us try to find and solve another question we have, because now we have solved only 5 numericals. Now we'll try to solve another 10 numericals of this exercise. We'll try to solve 15 questions today. We have just solved 5 questions. So now let us try to solve the 6th one. Okay. And now I hope it's clear to everyone that this concept is very easy. Okay, so now let us see what do we have in this 6th question. I have x dy minus y dx is equal to x square plus y square under root dx. Okay, so they have made this question a little bit tougher. Let us see how we will be able to solve it. So we can do x dy is equal to x square plus y square under root plus y, we can take dx. So now dy upon dx, it will be x square plus y square plus y upon x. Okay, so now we will try to solve this. How? Let us first find whether it is homogeneous or not. So xy is equal to, equal to x square plus y square under root plus y upon x. So now what we can do here, I'll replace it x by kx and y by ky. Okay, so we have kx ky is equal to k square x square plus k square y square plus ky upon kx. So now I can take k square common, so it will be k x square plus y square under root plus y upon x upon k. So you can write here 0 fx. Okay, so finally I can say this is a homogeneous. Therefore, it is homogeneous differential equation. Okay, so now let us try to solve this. Let y is equal to vx, dy upon dx is equal to v into differential plus x into dy upon dx. So now we'll try to solve this. We'll put the value of dy by dx here. We have x square plus v square x square plus Vx upon x is equal to V plus x dV upon dx. Now let us solve. X square taking common, so it will become x common, so we have 1 plus V square plus V upon x. We have x now, so now reduced, we have V plus x dV upon dx. Okay, so that is how we are able to solve this, and I got this plus V minus V is equal to x dV upon dx. So we have 1 upon x dx is equal to dV upon 1 plus V square under root. So we all know the integration of under root 1 plus V square a square plus x square. Now here we will have log x is equal to, we'll have, let us see. Now we know the formula here. We have log of, we can say here, that is the formula I have x plus, that is V plus c. So this is the formula I have. Now we can put the value of V here, that is we have taken y is equal to Vx, so we will be y upon x. So log y upon x plus 1 plus y square upon x square under root plus c. Okay, so we got this. We can leave it as it is, but let us try to take y upon x plus x square plus y square upon x square plus c. Okay, so now we can see log of x is equal to y, we have log of y upon x plus x square plus y square under root upon x. We'll take that side. Log of x minus log of y plus x square plus y square under root upon x. See. So now we know that log of a minus log b is equal to log a upon b. So I will try to put this x upon this. So we have x will reduce, we'll have y plus x square plus y square is equal to c. Now we'll have 1 upon y plus x square plus y square under root is equal to e raised to power c. Okay, so that is how we easily solve this numerical, or else you can put c. So easily find the general solution of the given homogeneous differential equation. Now let us try to solve another one. We have just solved only 6 questions. Now we'll try to solve the 7th. We have solved 6 questions here. Now we'll try to see how 7th question will be solved. Now we have 7th question here, that is x cos y upon x plus y sin y upon x. We have y dx is equal to y sin y upon x minus x cos y upon x. We have x dy. Okay, so now let us try to solve it. We have this, we'll take this upon this. Okay, dy upon dx. So dy upon dx will be this. So we'll have is equal to x cos y upon x plus y sin y upon x, y upon y sine y upon x minus x cos y upon x, x we have. Okay. So we can say what we have done here in a very simple way. We have taken dx that side, so this will be here in the denominator because here it is multiplied, so it will be in the divisible form. Okay, so now let us check. Let is equal to x cos y upon x plus y sin y upon x, y I have, upon y sin y upon x minus x cos y upon x, x we have. Now replace x and y by kx and ky. In all these questions, first we need to find whether the given differential equation is homogeneous or not. Then we'll proceed further to find its general solution. Okay, so now let us try. Now here we have kx cos ky upon kx plus ky sin ky upon kx. Y upon we have ky sin ky upon kx minus kx cos ky upon kx. Here we'll put ky kx. So we can see here, I can take k common, so I can find k square upon k square, and here we have x cos y upon x plus y sin y upon x, y upon we have y sin y upon x minus x cos y upon x, x, yeah. So I can say k is for 0 is equal to fxy. Okay, so we can say therefore they have the same degree, so we can say therefore it is a homogeneous differential equation. Okay, now let's try to solve it. What we will do, let y is equal to vx, so differentiating it, we got v plus x dv upon dx. Now we'll try to put a value here. So I got, now let us try to solve here, dy upon dx. What we have this, so x cos vx upon x minus vx sin vx upon x, all we have vx upon vx sin vx upon x minus cos vx upon x whole x. Okay, now we have, what we can do here, we'll reduce this, no? Is equal to v plus x dv upon dx. So we have x cos v minus y we have put no vx, vx sin v upon vx sin v minus cos v, minus v is equal to x dv upon dx. So now x cos v minus vx sin v minus v square x sin v minus v cos v upon we have vx sin v minus cos v is equal to x dv upon dx. So we can see here we have x cos v upon, so v minus y we have taken vx So 1x vx, so they have this. Okay, the v also there, so we can multiply v inside. Xv cos v minus v square x sin v. Okay, so now what we can do here, we can see what we have, minus we have, no. So now if I take LCM here, minus v, so minus v square x sin v, we have plus v cos v. Okay, so now we'll try to see, we have xv cos v here and we have v cos v. Okay, wait, we have done a mistake here. We have x here, so it will be minus x, so it will be vx cos v reduced, and wait, we have here y, vx we have taken, vx we have taken, y we have, vx v, and x we have, no. So now what is left with us is what you can see here. So 1 upon x log x integration, we got this vx sin v minus cos v upon, what we have, x cos v, x cos v upon minus 2v square x sin v. Okay, so now let us try to find its general solution here. We'll try to solve here first. So 1 upon x dx. So we got log x is equal to, we can take x common, x will be reduced, so we have v sin v minus cos v upon, take minus sign, we have, wait, here we have vx, no, this we have, no, minus 2v square x sin v. So x is reduced, we'll take minus half common, so we have inside v square sin v dv. Okay, if I separate it out, what I will get here, minus half v sin v upon v square sin v dv, minus half, here also it will be cos v upon v square sin v dv. Okay, so it will be plus v square sin v. Okay, so now I have taken this, so log x is equal to 1 upon v, so we have minus half log v plus, here what we can do here, it will be 1 upon 2 here, cot v upon v square dv. Okay, so now what we can do here, we can now integrate it by parts. Okay, so now we have, we can put here log x is equal to minus half, what is va, v will be y upon x. So now we need to integrate this. Okay, so now we'll try to solve this. What we have here, instead of, now we have log x is equal to, we'll separate it. Okay, so now cos v dv minus cos v upon 2v cos v dv. Okay, so now we have log x is equal to half tan v dv minus, here we'll have 1 upon v dv. Okay, so likewise we can easily solve this. So I got log x is equal to half of tan v is equal to log of sec v minus half log of v. Okay, so I have got this, that is log of x is equal to, so we have plus c, or here I can take this log of x plus log of c. So now we can write log of xc is equal to, I can take square or we'll take half common here, so we'll have log of sec v minus log of v. Okay, so 2 log of xc here, I can see that I can write here log of, we have sec is 1 upon cos. So first we will try to log of sec v upon v. So now we have, if I erase this, let us try to solve it here. So now this is the question we have. We will try to see log of xc whole square will have 1 upon v. We have taken the y is equal to vx, so x upon y will have log of, you can see here, log of sec v. Sec we have y upon x. Okay, so we have taken this now, or what else we can do here, we can take it as it is, that is now removing log we have, so we have xc whole square is equal to, we have here y upon x, sec we can take cos, will take as it is x upon y, we have cos y upon x. Okay, whole we can take it down. Okay, but now we have 1 upon xc whole square is equal to x upon y cos y upon x. Okay, so that is how we can easily solve this. So we have xc square is equal to this we have. Okay, so that is how we able to find the general solution. Now let us try the next question. So now we have the next question. We have just solved only 7. We have solved only 7 numericals. Now let us try to solve the 8 numerical I have. Okay, so now what is the 8th question we have? Let us see what they have given. That is x dy upon dx minus y plus x sine y upon x is equal to 0. Okay, so this is the question I have. So now let us see how we'll able to solve this. What we can do, take whole on that side. Okay, so now I have, that is y minus x sine y upon x, or dy upon dx is equal to y minus x sine y upon x upon x. So now we'll see that whether this differential equation is homogeneous or not. So we'll try to see how to solve this. So we have here, that is y minus x sine y upon x upon x. Now replace x and y by kx and ky. Kx and ky, so we'll have ky minus kx sine ky upon kx upon kx. I'll take k upon k common. We have y minus x sine y upon x upon x. Okay, so I'll reduce this. We can write k is for 0 and fxy. So we can say same degree they have. So we can say this equation is a homogeneous differential equation. Therefore, it is a homogeneous differential equation. Now let us try to solve. Let y is equal to vx, so dy upon dx is equal to v plus x dv upon dx. Okay, we'll try to solve it by uv differentiation method. Now what is dy upon dx? We'll try to put vx minus x sine vx upon x is equal to v plus x dv upon dx. X common will be reduced, so we have v minus sine v upon nothing we have now. Okay, v minus sine v. Now minus v is equal to x dv upon dx. Okay, so that I have. So now 1 upon x log x is equal to minus dv upon sine v. Okay, so now what I can see, log x plus c is equal to what I am doing here. Yes. Okay, now we'll see here we have cosec dv here. Okay, so now we'll try to integrate it here itself. So now we have log x plus c is equal to, now what we can do here, we can easily, okay, wait. Now we have here, this is minus, so now what we can do, minus log x plus, here I can take log c, and here we have now, that is log cosec minus log, we have cosec minus cot, cosec v minus cot v. Now I can say log c upon x is equal to, you can say log cosec y upon x minus cot y upon x. Okay, so now c upon x is equal to, what is cosec? I can put 1 upon sine y upon x minus cos y upon x sine y upon x. So now I can write here 1 minus cos y upon x is equal to sine y upon x into c upon x. Okay, so which is the required general solution of the given homogeneous equation. Now let us try to solve next one. We have just solved 8 questions. Now we'll try to solve the 9th one. We have solved only 8. We'll try to solve more questions we have. Now let us try to solve the 9th question we have. So what is 9th? 9th I have, that is y dx plus x log y upon x dy minus 2x dy is equal to 0. 9th we have y dx plus x log y upon x dy minus 2x dy is equal to 0. So now we'll try to separate it so that you can easily find. Now y dx is equal to 2x minus x log y upon x. Here we have dy. Now dy upon dx is equal to y upon 2x minus x log y upon x. Okay, so I have this. So now what we'll do, let fxy is equal to y upon 2x minus x log y upon x. Okay, so now consider, replace x by kx and y by f or ky. So kx ky is equal to ky upon 2kx minus kx log ky upon kx. Okay, so now I can take k common here. So I have y upon 2x minus x log y upon x. So now what we can do here, in a very easy way, we can write k is for 0 fx y. So it means therefore it is a homogeneous differential equation. Okay, now let us solve it first. So now we will write let y is equal to vx. We'll put a substitution here. So dy upon dx is equal to v plus x dv upon dx. So now what is dy upon dx we have? You can put here vx upon 2x minus x log vx upon x. Okay, so now we have this y is equal to v plus x dv upon dx. Okay, so now x is reduced by taking common from both numerator and denominator. We have v upon 2 minus log v minus v plus x dv upon dx. Okay, so we have taken v from the RHS to the LHS. Now let us try to solve it further. So now what will happen if I solve this? V minus 2v plus v log v is equal to x dv upon dx. So now we can say minus 2v. So we'll say minus v plus v log v. Okay, log v is equal to x dv upon dx. So I can write 1 upon x dx. Now integrate. So we have dv upon, if I take v common here, okay, so we'll have, or we'll take like this only, minus v plus v log v. Okay, so now let us see how we'll able to integrate, where we have log x plus c is equal to this. So now if I take log v as u or something like, but not we can't take like this, we have to take common something. So minus we are taking now v as common, so we have log v minus 1. Okay, so likewise you can do it. Now let us try to solve here what we were doing in that case, that is we have 2 minus log v. So now I can write 1 upon x dx is equal to 2 minus log v upon minus v plus v log v. So now I need to integrate this. So I got log x plus c is equal to 1 minus log v minus 1 upon, I can write, if I take common v, so we have log v minus 1 dv. Okay, now if I separate it, I got log x plus c, okay, is equal to, we have, if I separate this out, I got 1 upon v log v minus 1 dv minus dv upon v. Okay, so now my next step will be log x plus c is equal to, I have to log v minus 1 like this we have to. So now put log v minus 1 is equal to t, put log v minus 1 is equal to t, v minus 1 is equal to t. So we have 1 upon v dv is equal to dt. So we have, it will be dt upon t, that is log t. So log t is what? Log v minus 1 minus log v. Okay, So now what I can do here, I can write log x c, okay, is equal to, if I take log common, log v minus 1 upon v. So what we'll have? Reduce this. So we'll have xc is equal to log v, we have taken y upon x minus 1 upon y upon x. Okay, so that is how we able to find the general solution if we able to find that the given differential equation is homogeneous or not. Okay, now let us try to solve this. Ninth question we have done. So now we have to solve further questions. Okay, so now we have the 10th question. Now what the 10th question says, let us see. That is 1 plus e raised power x upon y dx plus e raised power x upon y 1 minus x upon y dy is equal to 0. Okay, so we have this question. Now let us see how we can solve 1 plus e raised power x upon y is equal to minus e raised power x upon y 1 minus x upon y dy. So now what we can do here, we have dx is equal to, so now we can take this dy upon dx. So dy upon dx will be minus of 1 plus e raised power x upon y upon e raised power x upon y 1 minus x upon y. Okay, so that is the question I have. So now what we can do here, let us try to solve. We'll try to take, let f of xy is equal to minus 1 plus e x upon y upon e raised power x upon y 1 minus x upon y. So now we'll replace here x and y by kx and ky. So kx, ky will have minus 1 plus e raised power kx upon ky upon e raised power kx ky 1 minus kx upon ky. Have this. So now what I say, I can take common from this. So we have, we'll take the common from here. So we'll have k upon k. Okay, we have 1 plus e raised power x upon y upon e raised power x upon y 1 minus x upon y. Okay, so I have this, so I can write k raised power 0 fxy. Okay, so you can say, therefore it is a homogeneous differential equation. Okay, so we have, now after rearranging it, we find that dx upon dy is equal to minus e raised power x upon y 1 minus x upon y upon 1 plus e raised power x upon y. Okay, so now we'll substitute, let y is equal, we'll take here x is equal to vy. So now we'll differentiate dx upon dy is equal to v into dy upon dx plus y into dv upon dx. Okay, so let us see how we can solve this. And now what will happen? We'll put the value of dx upon dy. We have minus e. We have vy upon y. 1 minus vy upon y upon 1 plus e vy upon y is equal to v plus y dv upon dx. Okay, so now let us see what will left with us. We have what we can see here. We have minus e raised power v 1 minus v upon 1 plus e raised power v minus v is equal to y dv upon dx. Okay, so now we can take minus ev plus e raised power v into v minus v and minus v into e raised power v, so it will be reduced. So we have 1 plus ev is equal to y dv upon dx. Okay, this we have, thus we have multiplied inside, so we got this. Now what we can do here, I will try to now we will try to solve it. So now we have, if I take this y dx, okay, 1 upon y, will we have dv upon dy here, okay, on dy. So we have 1 upon y dy here, and here we'll have 1 plus ev upon, if I take minus sign common, we have v plus ev here, okay. So it's very simple. If I take this common, v plus ev, we have log y plus c. Here we have, if I take this t, so it will be 1 plus ev dv is equal to dt. So 1 upon t will be log t. So we will have log t, we have 1 plus e raised power v. Okay, this much we have, minus log 1 plus ev. So now we can say 1 plus ev dv is equal to dt I have taken. So it will be, what we have taken, v plus ev is equal to t. So we have 1 plus ev whole dv is equal to dt. Okay, so we have 1 plus ev dv is equal to dt. So 1 upon t is equal to be log t. Okay, so we have, so now we can easily say, if I write log y plus log c, if I write this, minus log of 1 plus ev, so we have log yc is equal to minus 1 plus ev. Okay, so now we can write yc is equal to minus 1 plus e raised power v, but we have taken v x upon y. Okay, so that is how we able to find the general solution of the given differential equation. Now let us try to solve 11th. Next question. We have just solved only 10. Now we'll try to solve 11th. Now let us try to solve the 11th question. What they says about the 11th question is, they have x plus y, we have dy plus x minus y, they have dx is equal to 0, and also they have given the condition, that is y is equal to 1 when x is equal to 1. Okay, so now what we can do here, we can take this side, x plus y dy is equal to x minus y dx. So now dy upon dx, we have minus x minus y upon x plus y. Okay, so now let fx y is equal to minus x minus y upon x plus y. Let us replace x and y by kx and ky so that you can easily know whether it is homogeneous equation or not. So now let us see, we have minus kx minus ky upon kx plus ky. So we have take minus sign common here. So what we'll do here? We'll take common k. So we have minus x minus y upon x plus y. So I can write it k is for 0 minus x minus y upon x plus y. I can write it k is for 0 fxy. So we can say this is a homogeneous. It is a homogeneous differential equation. So now we have what we can do. Let y is equal to vx, substitute it. We got dy upon dx is equal to v plus x dv upon dx. Now putting the value here, what is dy upon dx? We have minus x minus vx upon x plus vx is equal to v plus x dv upon dx. So now what we can do here, x common, it is reduced, so we have 1 minus v upon 1 plus v. Minus v is equal to x dv upon dx. Take this minus outside, so we have 1 minus v and plus v square. 1 plus v x dv upon dx. So what will happen here? 1 upon x dx is equal to, it will take upper side 1 plus v upon 1 plus v square dv. So now what we can do, separate it out. We got log x plus c is equal to 1 upon 1 plus v square dv plus v upon 1 plus v square dv. So we have minus log x plus c is equal to 1 upon a square plus x square, and root will have tan inverse v plus we have, we'll take t here, so 2v dv, so 1 by 2 dt upon t, this will be log of 1 plus v square. Okay, so now my next step will be, we'll try to put a value again. Plus c is equal to tan inverse y upon x plus half log 1 plus v square. V square will have y square upon x square. So now here I can put a value. I got this. If x is 1, y is 1. So we have minus log 1 plus c is equal to tan inverse 1. So 1 will be pi by 4 plus half 1 plus 1. 1 plus 1. Okay. So we have 1 plus 1 will be 2. So we have 1 by 2 log 2. So I got this value. So now what I got here, minus log minus 1 plus c I have, it will be 0. So we have minus c is equal to pi by 4 plus log root 2, or c is equal to, I have c is equal to minus pi by 4 minus log root 2. So now I can put this value where I need to put. You can see I can put here, because I have solved this one. V is equal to this, we have solved. So we got dy upon dx is equal to, we have solved this. Okay, so you can now put the value here itself. Okay, So that is how we able to solve this numerical. That is, we able to find the differential. We are able to find the homogeneous. We are able to find the general solution of a given homogeneous equation, differential equation. Now we'll try to solve the next. We have solved only 11 questions today. Now let us try to solve the 12th. 12th question I have. So what is 12th they have given? X square dy plus xy plus y square dx is equal to 0. And they have given y is equal to 1, x is equal to 1. Okay. Y is equal to 1 when x is equal to 1. Okay. So now I have this. Take x side common, minus xy plus y square dx, or dy upon dx will be minus xy plus y square upon x square. Okay, now what we'll do, let us find whether this equation, differential equation, is homogeneous or not. So now we'll try to solve it. We have minus xy plus y square upon x square. So now we have, we'll replace x and y by kx and ky, minus k square kx and ky. So we have k square xy plus k square y square upon k square x square. What we can do, we'll take xk square common. So now what will I have? So it will have minus x, we have xy plus y square upon x square. Okay, so we have this. I can write this, k is for 0 minus, I can write this f of xy. Having the same degree, so we can say that it is a homogeneous differential equation. It is a homogeneous differential equation. So now I will try to solve. Let y is equal to vx. Now dy upon dx is equal to v plus x dv upon dx. Now try to put the value of dy upon dx. What we have? Minus x square v plus v square x square upon x square. It is v plus x dv upon dx. So now what we can do? Eliminate x square from both numerator and denominator. Now we have v square plus v upon 1 minus v. Will try to solve this, is equal to x dv upon dx. So now we have reduced this, we got v minus v square. So 1 upon x dx, here minus we have, so we have dv upon v square. We all know this, minus log x plus c is equal to 1 upon v square. It will minus 2 plus 1, minus 1. Okay, minus v square we have, so we take v square upper side, minus 2, so minus 2 plus 1 upon minus 2 plus 1. So we have here, that is minus log x plus c is equal to minus 1 upon v. Okay, so now put the value of v here. So log x is plus c is equal to minus, what is v here? 1 y upon x. Now put the value. If I put x is equal to 1, so log of 1 plus c is equal to minus 1 upon 1. It will be, so it will be 0. Log 1 is 0 we have. so we have the value c is equal to -1. Okay, so I can put this value here. It is minus log of x minus 1 is equal to -1 upon y upon x. What we can do? We can easily take minus sign outside. So we have log x plus 1 is equal to 1 upon y upon x. Okay, so that is how we are able to find the general solution of the if we are able to find that the given differential equation is homogeneous, so we can easily find its general solution. Okay, so now let us try to solve next one. Now let us try to solve the next question, 13th. So now we have 13th question to solve. We have solved 12 questions today. Now I'll try to solve the 13th one. What they have given? 13th question, that is x sine square y upon x minus y. Okay, so this is dx plus x dy is equal to 0, and they have given y is equal to pi by 4 when x is equal to 1. When x is equal to x sine square y upon minus y dx plus x dy is equal to 0. So now how we'll do? Let us see. We'll take this side x dy is equal to minus of x sine square y upon x minus y dx. Now dy upon dx will be minus of x sine square y upon x minus y upon x. Okay, upon x we have. So now let us see whether this differential equation is homogeneous or not. So f x y is equal to minus x sine square y upon x minus y upon x. So now replace x and y by kx and ky. So kx ky is equal to minus kx sine square ky upon kx minus ky upon kx. So you can take k common here. So we have k upon k minus of x sine square y upon x minus y upon x. So I can write this 0. We have f of xy. So we can say they have the same degree. So we can say it is a very homogeneous differential equation. Therefore, it is a homogeneous differential equation. So now we'll solve. Let y is equal to vx. So dy upon dx is equal to v plus x dv upon dx. Now I is using v using AB UV differentiation. Now what is dy upon dx? We have this. So we'll try to put this minus x sine square v x upon x minus vx. Okay, upon we have x. Now we have v plus x dv upon dx. Now after eliminating x from numerator denominator, we have minus sine square v minus v we have is equal to we can take v here. Okay, so is equal to x dv upon dx. Okay, sine square we have this now minus sign we have. So now what we can say here, 1 upon x dx is minus we have, well now dv we have sine square v minus 2v minus sine sine square v minus 2. So now we have minus log x plus c is equal to. Okay, now let us see how we can easily eliminate this. Now we can easily understand this, that if I solve this, so what I will get here, this sine square v, so it is cosec square v dv. So now we have minus log x plus c we have is equal to minus cot v. So we have this. So now log of x plus c is equal to cot of y upon x we have. Now they have given the value so that we can put the value here. Now we can put a value if x is 1. Okay, x is 1 we have, y is pi by 4. X is 1. Cot pi by 4, it will be 1. So c is equal to 1 we have. Here I can put the value here. So I have log x plus 1 is equal to cot of y upon x plus 1. So that is how we are able to find the general solution of the homogeneous differential equation. Now let us try to solve 14th question we have. We have just solved 13. So now we'll try to solve 14th. We have solved 13 questions now. So now we'll try to solve 14th question. So now what they have given, let us see. They have given dy upon dx minus we have y upon x plus cosec y upon x is equal to 0. They have given y is equal to 0 when x is equal to 1. Okay, so now let us see what we can do here. Just try to solve dy upon dx is equal to y upon x minus cosec y upon x. So now let us take this xy is equal to y upon x minus cosec y upon x. So let's replace x and y by kx and ky. So kx and ky. We have ky upon kx minus cosec ky upon kx. So we can easily say this, taking k upon k common, that is y upon x minus cosec y upon x. Okay, so we can say easily that is k is for 0, we have f of x and y. So we can say easily, we can say therefore it is a homogeneous differential equation. So now what we have, we can easily say y is equal to vx. So dy upon dx is equal to v plus x dv upon dx. So now what is dy upon dx? We have this. So vx upon x minus cosec vx upon x minus v is equal to x dv upon dx. So we have v minus cosec v minus v is equal to x dv upon dx. So now we have 1 upon x dx minus is equal to, we have dv upon cosec v, but we can write here minus log of x plus c is equal to sin v. So we have minus we have sin v dv. So we can write plus c, we have minus cos v So minus minus reduced. So now I can put a value log x plus c is equal to cos of y upon x. So now we can say what is we'll put a value of x is 1, y is 0. So we have plus c is equal to 1 cos 0 is 1. So we can say c is equal to 1. You can put the value here. So finally we are able to find is equal to cos y upon x. Okay, so that is how we are able to find the general solution of a homogeneous differential equation. Now let us try to solve next question. 15th question. 15th question will try to solve. Now what is the 15th question we have? I have in my hand. Let us write this 15th question. 2xy plus y square minus 2x square dy upon dx is equal to 0. Okay. Now what they are asking, they are saying y is equal to 2 when x is equal to 1. Okay. So now let us try to solve this. We can what we can do here, we can take this 2xy plus y square is equal to 2x square dy upon dx. Okay, so now dy upon dx is equal to 2xy plus y square upon 2x square. So we say let f of xy is equal to 2xy plus y square upon 2x square. Now, in order to know whether this differential equation is homogeneous or not, we'll replace x and y by kx and ky. Okay, so now I have 2k square xy plus k square y square upon 2k square x square. Now we can take it common. So we have k square upon k square. We have here 2xy plus y square upon 2x square. So I can say this k is power 0 f of xy. So we are able to know that they have the same degree of the coefficient of dx and dy. So we can say that the given differential equation is homogeneous. Therefore, it is homogeneous differential equation. Okay, so now we can use let y is equal to vx. So we will have dy upon dx is equal to v plus x dv upon dx. Now put dy upon dx, we have 2x square v plus v square x square upon 2x square v plus x dv upon dx. Now we can take x square common, so we have 2v plus v square upon 2. Okay, so now we have is equal to v plus x dv upon dx. So now we can take 2v plus v square minus 2v upon 2 is equal to x dv upon dx. So now we have what? V square upon 2 is equal to x dv upon dx. 1 upon x dx we have, so we can write 2 outside and we have dv upon v square. So now we'll try to integrate log x plus c is equal to 2 v minus 2 plus 1 minus 1 upon minus 1. So we have log x plus c is equal to minus 2 upon v. So we can say, write the value here, log x plus c is equal to minus 2 upon y upon x. So now put the value. If x is 1, y is 2. So x is 1, y is 2. So minus 2 upon 2 is equal to minus 1. So c is equal to minus 1. So we can put the value here and we can say log of x plus log of x minus 1 is equal to y upon x. Okay, which is the required general solution of the homogeneous differential equation. We have just solved 15 questions from this exercise. If you have any doubt, you can comment, you can ask, you can share, and also like my channel. Thank you.